Well, good afternoon, everyone, and welcome to our seminar on AI ethics and research. My name is Jody Reeves from National University, and I'm the Associate Director of Education, Outreach, and Diversity for TILOS, our NSF-sponsored AI Institute. It's my great pleasure to introduce you to our speakers today. First, Dr. David Danks at UC San Diego will describe how he develops practical frameworks and methods to incorporate ethical policy considerations throughout the AI lifecycle. He will speak for about 20 minutes or so and then take questions until the bottom of the hour. Then, Dr. Nisheeth Vishnoi at Yale University will give his presentation. Professor Vishnoi uses optimization as a lens to study how subjective human and societal biases emerge in the rather objective world of artificial algorithms, as well as how to design strategies to mitigate those biases. After his presentation, he will take Q&A from the audience as well. So without further ado, I'll turn it over to Dr. David Danks at UCSD. Thank you both for being here today.
Thanks so much, Jody, for the invitation to come and talk to the TILOS folks. I guess I am now a TILOS folk as well, as an affiliate of the Institute. So what I wanted to do was perhaps talk a little bit about issues. And I should say, by the way, I'll have chat up and running. So if people have questions that they want to just drop in chat, I'm also happy to sort of take those in real time rather than waiting until we get to the end of the Q&A. But I wanted to talk about an issue that I think is sometimes hard for us to sort of wrap our heads around, which is when we're doing very foundational or seemingly abstract research, things that don't connect with the uses in the real world, what are the considerations of ethics that matter? And in this regard, I think it's useful to start by just thinking about what do we mean even by ethics? I think oftentimes people think of ethics. One way of thinking about ethics is that it's about compliance, whether legal compliance or norm compliance in the world, right? Ethics is about, at least in research, it's about, make sure you complete your IRB applications if you're doing human subjects research or this sort of thing. So that's one kind of picture. It's about compliance. Another one that actually I often hear, especially in spaces around AI, is ethics, sort of the idea of ethics as the fun police. Right? Somebody has this really cool idea of a new algorithm or a new product or a system that they could develop and deploy. And the ethicist comes in and sort of wags their finger and says, no, 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 don't do that. I want to suggest both of those are the wrong way to think about ethics. Ethics is not about compliance with some set of rules that we can lay out in advance. And it's not about somebody coming in as an external critic and telling you that you should be doing things differently. Instead, ethics is fundamentally, I would argue, about our values. It's about thinking about the things that matter to us. So I value being a good colleague. I value being a good father. Those things can come into conflict with one another, as we all know from thinking about work-life balance issues. I value living in a thriving community. I value having resources for myself. Those come into conflict when we think about things like paying taxes, right? So the world and our lives are filled with conflicts between values, both our personal values, right? So within myself, there are conflicts in terms of the values between people, right? So you, Sue, and I surely have slightly different values, and that can lead to conflicts, whether small or large. So we think about values as what matters to us, then we recognize that those are going to imply certain kinds of behavioral constraints, behavioral implications, including in the conduct of research, right? So the values that we have are going to shape the ways in which we do research. And I'll talk about that more on the next slide, but I want to sort of get that out there at the very beginning, that we, in part, when we are doing research, when we are building systems, it is not this sort of purely objective, the numbers come in, the model pops out process that we, quite frankly, many of us probably teach our students, right? Where we focus on the algorithm, we focus on the model class, we focus on the implementation in this language or that framework. But in fact, if we think about the broader research endeavor, it is much more than just proving a theorem. And so there are many places that values enter into our research considerations. Now, I've been using the word values, but of course, this is supposed to be about ethics. So when we talk about ethics, I think most of normative ethics, so normative ethics, that's just the what ethics ought we have. This is sort of the province of when I'm wearing my philosopher's hat, this is part of what I worry about. And so here I think normative ethics is really concerned with two main questions. The first is, what values should someone have? Right? So should I have the value of, valuing being a good colleague? Is that even something I should value? Should I value other people's prosperity? You might think, if you're so I guess a sort of a hardcore libertarian, you might say, no, you shouldn't bother valuing other people's prosperity. And so one set of questions is that. This is, I think, a very challenging question to ask. I want to make sure to acknowledge that it is an issue that comes up when we think about the development of AI systems, which is different people can have radically different values that can come into conflict with one another. At the very least, if I'm building a system, say, for loan approval, the values of the loan applicant and the values of the loan provider, those can come into conflict. And as a developer of an AI system, I have to figure out whose values am I going to prioritize, or how am I going to trade these off against each other. So there are questions about what values someone should have or what values should be implemented. The other piece of normative ethics that I think is more relevant to what we often are engaged in research and development is, given values, how should I behave? So if you've ever heard of terms like utilitarianism or consequentialism or deontology or virtue ethics, right? These are names for different ethical frameworks, in some cases meta-ethical frameworks. These approaches, much of what they're doing, much of the work in the framework actually is to provide a decision rule, which is, given what you value about the world, how should you act to resolve tensions between those values? How should you act to realize or implement those values? And so the question of, I value people's privacy, I value their autonomy in using my AI system, I value their security, and I'm building a surveillance network. How should I trade off these values against each other? That is a core ethical question. So I start out with talking about values, but then jump to ethics, because ethics is in many ways, I would suggest it's sort of the normative science of values. What values should we have? Given the values we have, how should we act in response? So what does any of this have to do with research? Well, what it has to do with research is, and here I'm going to focus on optimization because, of course, this is TILOS. And you might have said, well, look, optimization is not about ethics. I mean, optimization is, here's this problem, how do I solve it faster? How do I solve it better, right? That sounds a lot like math. That sounds a lot like computer science. Where's the ethics in those? This is just numbers, for example. Well, I think actually it shows up all over the place in thinking about research, especially in optimization. So just take the simplest one. What problem are we trying to solve? That's an ethical question. So the decision to try to solve problem A rather than problem B is an ethical decision. It is me realizing or prioritizing certain values that say this problem is worth solving. Now, in some cases, it's so obvious that the problem is worth solving that we don't even bother to, wonder about it, right? The problem of trying to have better diagnostic systems in a healthcare network. That seems sort of just kind of an obvious, that's something we should spend our time trying to solve. It can get trickier when we think about more abstract, more foundational research. But it may be that we're not quite sure what the direct real world relevance would be, but nonetheless, we think it's an important research question. And so the first thing that I would sort of propose, if you take just a few messages away from what it is that I'm saying today, one of the messages would exactly be that declaration that this is an important problem, that is a declaration of, or that is a function of your values. which is to say that the declaration that this is an important research problem in mathematics actually is an ethical decision, okay? Which is probably not a characterization most of you would have had coming into this. Or consider the question of what constraints we should include. I'm not saying all optimization is constrained optimization, but in general, what things matter? So when I'm optimizing or I'm doing research, do I care whether my algorithm can run in in the next 1,000 years, or do I ignore computational complexity? Do I care about the environmental cost of running an algorithm? Do I care about people, ethical constraints due to people's concern for privacy? Right? These are all questions of what constraints we do include or we don't. And even when we're developing algorithms, and when I'm doing sort of ML research and developing causal discovery algorithms, we're constantly having to think about, well, can we make this assumption or that assumption? Assumptions are fundamentally just constraints. They're things that we're saying we can assume this additional information. Right? But that is, again, a value-laden question because it's saying that some constraints are important and other ones are not. Presumably, none of us think that it matters whether the computer that runs an optimization algorithm is silver or pink or blue or black. We don't think that matters, so we don't bother to include as a constraint, well, this has to work on machines of this color. But that's a substantive decision that we've made, and we need to recognize that. Perhaps most obviously, ethics enters into optimization research when we think about the application of these things. When we think about, roughly what loss function are we optimizing for? More generally, what counts as success? So if I'm trying to optimize, I earlier said optimizing healthcare diagnoses, well, I could optimize for mean accuracy, for minimizing the distance to the right answer. I could optimize for reducing the fatality rate, the mortality rate, which means, I might be more willing to say somebody has a disease because better to overtreat than undertreat, right? So in some sense, from an optimization perspective, if you're doing theory, you might say, well, sure, we can optimize for any of those. We don't care. You just have to be able to specify the function. But when you're trying to translate optimization into any real world context, this is immediately where issues of what counts as success come to the fore. Because frequently what we have in mind is something that's much more amorphous, much more general, that can't be specified as just a single loss function. There might be multiple loss functions that are consistent with what we have in mind, say improving diagnosis or having less biased allocation of healthcare resources, trying to anticipate here the second half of this hour. The ways in which we capture that are going to prioritize certain values over others. So do we prioritize the welfare of the worst off? Do we prioritize the average welfare of our patients? Do we prioritize minimizing the variation in welfare across our patients, right? So nobody's too badly hurt in the worst case. Nobody's helped too much in the best case. Again, we can use any of those. It's an ethical choice to select this, one of those loss functions rather than another. It's exactly the fact that the mathematics doesn't care which loss function we use that is indicative of the fact that this is an ethical choice. When we think about building models, we're usually optimizing relative to some training data or some training test transfer data, but there's always risks. And when we move into deployment, we have to be asking, what are the acceptable risks? How do we manage those risks? These are, again, ethical questions because they're about which values we prioritize, which aspects of the problem we think are the most important ones to watch out for. Again, do we prioritize the value of caring for the worst off? Do we prioritize the value of raising the average welfare if we're thinking about the medical diagnostic case? Those might lead to very different recommendations when we think about transfer and generalization. Those might even lead to very different recommendations about which algorithms we use in the first place to train our model. So I could go on and on, but I wanted to leave time for questions. Hopefully people have some, because I find that that's often the more interesting part of these kinds of presentations. But I want to leave with sort of one really key take-home message, which is we are all, and I'm including myself in this group, when we're doing research in optimization, research in AI, we're already doing ethics. Okay, so it's very important to bear in mind, it isn't that, people talk, for example, about trustworthy AI. It's not that you can do your ordinary AI, and then there's this special kind called trustworthy where you get a gold star because it thinks about ethics and values. We're already making ethical decisions. We're doing this all the time. That's okay, right? It's okay to be doing this. You're not, even if you're sitting there going, but I'm not trained in how to make these ethical decisions. Okay, but you're making them anyway. So a lot of the research in AI ethics is about how do we do this in a more intentional way. So I do want to make sure, though, to sort of end on this message or end the presentation on this message, that ethics is not some extra thing that gets added into our research. It isn't that you can do research in a way that is non-ethical. I'm not saying unethical, right? That's obviously behaving badly. It isn't that you can be non-ethical in your research. You are always making ethical choices in your research in terms of the values that you prioritize in that research. The question is, are you being intentional, deliberate, and mindful, and in making these decisions on the basis of the right kinds of reasons? And those practices, that's where a lot of the research comes in for, when I'm putting on my AI ethicist hat and doing research on it, a lot of what we're trying to do is come up with practices and ways to help people make better decisions. It's not that these are new decisions, it's that we want to have them be better decisions. So with that, I'll go ahead and stop, actually short of 20 minutes, but I hope that's okay, Jody. I figured Q&A is more fun for these things anyway.
That's fantastic. Thank you so much, David. I'll start with the first question, then we can open it up to the audience, which is a mixture of our colleagues in TILOS, students, postdocs, and others from National University and other universities. My first question is, when you talked about trustworthy AI, I guess the assumption I make when I hear that is it's intentionally, ethically, either neutral or perhaps even positive. Can you talk a little bit more about what is considered trustworthy AI?
Sure. Yeah, so the language of trustworthy, well, there's actually a sort of mix and match that's occurring these days. You've got a list of adjectives: trustworthy, reliable, responsible, beneficial, and then you've got a list of nouns: AI, machine learning, data, decision support systems, and every combinatoric that you can imagine, every combination is, you'll find it. And people don't actually mean radically different things by that. So let me start with that. Right now, the language is being used in, I think, very loose and not particularly intentional ways. But when we talk about specifically trustworthiness, trustworthiness is really about a kind of alignment of values. So I can legitimately, responsibly trust another when I have good reasons to believe. I'm sort of speaking a little bit loosely here. I don't want to bore people with a philosophy thesis. But when I have good reason to think that the trustee, the one that I'm trusting, is going to act in ways that support my values, right? So I'm willing to make myself vulnerable. I'm willing to leave myself open to harm because I'm trusting that they're going to look after the values that matter to me. And so it's the same. The reason I put the formulation in this way is because that way of thinking about trustworthy means that there's nothing about the trustee there that it actually has to be a human, right? So a trustworthy AI system is one that I have good reason to think is going to look after the values that matter for me. So I'm willing to, not bother to check the results of the AI system, right? I'm opening myself to harm because I'm not double checking what it says, but I'm doing that because I think it's going to support my values. It's going to help me be a better teacher. It's going to help me be a better driver on the roads, if we're thinking about whether a self-driving car is trustworthy right now. Whether it will care for an aging parent. If we think about geriatric-centered aging robots, care bots. So that's the notion of trustworthy AI. And that centers this conception of values. It forces us to think about what are our own values and what are we trying to have the AI system support. And then we have to ask the really hard question of, okay, are those actually the values that are implemented, realized, and advanced by the AI system, right? So that's where we have to think about, how was it developed? How was it tested? Where has it previously been applied? What has its performance been in those cases? Where are the edge cases where it's going to fail? So we have to ask many of the questions that I think we're used to asking in terms of test, audit, reliability, these kinds of things. But it's all in the context of thinking about whether the system is supporting our values.
Excellent. Thank you so much. I'd now like to open it up to questions from the audience. You can unmute yourself, ask your question, or feel free to type it in the chat window as well. Any other questions?
Everything I said
Maybe
is deep and profound, and nobody has any questions.
no, David, actually, I'm curious. I mean, maybe just follow up what you said at the end. I mean, with a message that everyone is already making all these decisions consciously or unconsciously. But you mentioned that, for example, your research is on how to do research to see how to help people to make better decisions. I'm wondering whether you can elaborate a bit more on that front. Yeah.
Sure. So the kinds of work that I've been doing have taken several different forms. So one form is touching on things around policy and regulation. So this is where the state, in some sense, is enforcing the ways that we design and develop these systems. The perhaps more interesting line of work for purposes of many of the people on this call is work around essentially what questions should we as researchers ask. So we actually worked collaboratively with the data analytics group and came up with a kind of, in 5 minutes, can you figure out whether there are reasons for you to, call and get some help in thinking through the ethical issues? So we refer to it as ethics triage. How do I sort of figure out where my energy is needed? Because the reality is some kinds of research questions, they do require ethical decisions, but they're ones that are, I think, a little bit clearer to people, right? So if I'm building a diagnostic system, it's kind of obvious that I'm going to need to think about what is it that matters to patients, what is it that matters to the doctors, what does it matter that matters to the nurses. It's sort of clear that we need to think about these things. But if I'm doing something where I want to monitor social media, entirely public social media posts to figure out whether my employees are potentially going to suffer from depression or burnout, you might think that that's unproblematic, right? I'm using public information to try and help people. But there actually are a lot of complex issues that arise in those kinds of things. So that's where working with people who are thinking about this is important, but you have to know who to call and when to call. So it sort of runs the gamut, right? From a checklist set of questions all the way to what kinds of policy should a country enact. Parts of it are developing new algorithms, because if we can have better defaults, right? We know most people are just going to use whatever is the default algorithm or the default parameter setting. If we can have better algorithms as our default, and better in the sense of more likely to support the values that are driving the inquiry, then that's going to be a positive change. So I actually view a lot of the work I do in AI development ends up being, in part, how do we get better models at the end, more ethically defensible models at the end, even though it isn't always framed in that way.
Thanks.
Hi, David. I have one question.
Sure.
Okay, so it's a great presentation. So could you kindly share impactful examples of integrations, ethical framework in AI optimizations, and what innovative methods are used to measure and represent bias in AI system?
So methods to represent bias. So I don't want to step on Nisheeth's talk, because I'm guessing that he's going to talk a fair amount about bias. One thing I will say is, so right now, and this might even suggest, I don't know if this would end up being a discussion point after the next one, most of the measures of bias right now focus on essentially observable skews or differences in statistical distributions. So they're focused on, differences in false positive rates or differences in odds ratios between groups. I will say when I put on my, I'm 50-50 between data science and philosophy here at UCSD. And when I think as a philosopher, I look and go, but bias is not the behavior, right? So if we think about racism is not the behaviors in many cases. It is the underlying psychological states that lead to those behaviors. And I think one of the big challenges that we have in bias research right now is developing methods that can actually infer something about the unobserved causal, motivational structures that are leading to these behavioral differences. And the reason I say it that way is that there are plenty of cases where we have, for example, differences in distributions between two groups, but it's actually not a problematic kind of bias. As a simple example, I want my diagnostic AI, healthcare diagnostic AI, to have different false positive rates between men and women if we're doing diagnosis of prostate cancer. It had better have different rates in false positive between men and women, because biological women very, very rarely have a prostate. So it shouldn't be saying positives there. So sometimes those skews are perfectly fine. They're not things that we think we need to undo in any algorithmic way. Other times you can have absence of a skew, you can have the equality, but it's because there's some other factor that's obscuring an underlying bias that we think we should get rid of, right? So I tend to think that one of the big challenges we have right now as a community working in bias on problems of bias is exactly how do we go sort of from the observable to the unobserved that generates the things that we think ethically, socially, legally, we should be trying to undo.
Thank you, David.
Earlier, you had mentioned regulatory aspects, and could you describe a little bit about President Biden's executive order from a few months ago and how it's trying to put guardrails on AI research and what companies can do with AI and how ethics relates to all of that?
Yeah, happy to. So Jody is referring to Executive Order 14110, which came out on October 30th of last year. It's actually the longest executive order in the history of the United States. Executive orders, for those who don't know, essentially that's the president telling the executive branch of the U.S. government, so all of the agencies and departments that you would think of, telling them all, here's what we're going to do. Right. So it's not a law. It can be undone by a subsequent executive order, but it's essentially the CEO telling everybody, here's what we need to do going forward. And what's striking about the executive order, one piece of it does put restrictions on large companies building dual use foundation models. Think here GPT-5. But basically what it does, it just says, if you're going to build one of these massive models, or you're going to use huge amounts of compute, we, the US government, want to know about that. It doesn't tell them they can't do it. It just says, we want to know about it. Where I think it connects more directly with research is that the EO, first of all, it says for privacy enhancing technologies that we need to spend a lot more money doing research on those things. So if you work on privacy enhancing technologies, think here optimization for under differential privacy constraints. There's about to be a lot of money coming your way. So that's good for all of us. That's a kind of governance, by the way. Where we put our money shapes where the research goes. That's a very normal thing. The bigger thing, though, that is I think in the executive order that I think you were referring to, Jody, is it lays out a number of steps in terms of developing frameworks for creating and assessing trustworthy AI that the executive order says need to be built and will be used across the US government. Now, the executive order cannot say anybody else has to do anything, but the reality is that, if you look historically, when the US government has a mandate that you have to do things in a certain way, that very quickly trickles down to state governments, it trickles down to local governments, And companies just go, fine, we'll just do that because we want to have access to those markets. So on the one hand, it's just for the executive branch, but everyone expects these to then become at least de facto standards that many companies are going to start to follow. And the basic structure of the standards that are going to be developed through the AI Safety Institute, which is housed within NIST at in Commerce, the basic structure of those is that the systems that are built need to be responsive to the needs and interests of the communities that are impacted by them. So the thread that sort of runs throughout the EO is, if we're going to build AI that impacts people's lives, we have to figure out how we can actually benefit those people. Rather than presuming that we know best, you can think of this as sort of the ethics version of "you are not your user," that slogan that people in interface design have been hearing for 30 years. This is sort of the ethics version of that for AI. You are not the people who are going to be impacted by the system you're building. Don't presume you know what it is that they need. You have to do the work to actually engage with those communities, understand their needs and interests, and then ensure that the system is providing benefit to them. We don't know how to do that in a systematic way. There are lots of methods to do it: community-centered design, value-sensitive design, but actually having systematic frameworks that can allow a team of folks who are in their 20s in a startup to do this well. That's part of what the AI Safety Institute is exactly going to be developing, is what are those procedures to engage, to develop subject to what you learned in the engagement, to do test and evaluation, to do subsequent audit and monitoring for adverse events, and so on all down the line. So I would expect a lot of this to be forthcoming in the next, it's government, so double what you think it should take. And so that means a lot of things are going to be coming out probably in the next 6 to 12 months as toolkits that we can all use.
Wonderful. Thank you so much for that. And thank you for your thought-provoking presentation and discussion. I'd now like to turn it over to Dr. Vishnoi for his presentation and more Q&A.
Hi, everyone. Thank you, Jody and Yusu, and of course, David. I mean, I was actually, while you were talking, I was adding slides so that your talk could step on my feet. I think what you said very accurately. I mean, we did not coordinate at all, actually, just for the audience to know. But I think it's the same perspective. I guess this picture, which is generated using GPT-4, is as good a picture I could get from the prompt that I was trying to get to, which is that the AI that we are generating is an extension to ourselves. In many of the discussions I've had, one of the first things I feel, especially when I talk to non-computer scientists, is that AI comes from Mars. It doesn't. And as David very eloquently explained, that we are embedding our values, ethics, norms in these processes, in these algorithms, and largely without any awareness. And so what I'm going to tell you is a little bit of the story from the kind of the optimization or computer science point of view, leading to this realization that we are embedding our values. And here at Yale, I teach a course in which we do this deconstruction. We look at how are we embedding our values, what values are we embedding. So let me tell you that part of the story. I realize I have too many slides, but I will flash some of them just to give you a sense of, but I don't think here anybody needs an introduction on what AI algorithms are doing. Well, the big goal is to mimic natural algorithms. It is important to keep in mind what the goal is. It's not to solve abstract problems which may be of interest to Martians. It is to solve problems which are of interest to people living on this planet, and the word interest implies that these problems inherently embed some values. So if you, for instance, go and ask GPT, which is the most beautiful building architecturally, most likely the answer that will come out is Vatican. And that is because of the way the way this world is structured.
OXCQ, and then I'll finish recording.
Yeah. Okay. So this is, I think this came as a surprise to many people, especially who are working in the algorithms world, that how is this possible? How can algorithms, which live in this very precise mathematical world, have all these kind of failures, which are typically associated to humans? And the terms like algorithmic bias were coined, which are kind of examples of this principle of othering, where we are somehow associating the biases that we are seeing in algorithms to algorithms without really understanding how we are embedding our own biases and values. Okay, so let's talk about algorithms. So what do we teach in algorithms? So I guess in this audience, there are some experts in algorithms, and we have all taught these courses where I say, okay, here's a graph, find the shortest path. And most of the focus is on deriving methods to find a shortest path in a graph. We probably never asked this question, shortest path for what? What does shortest mean? How are we deciding whether the path is the shortest path or not? Probably in the 30s when roads were sparse and traffic wasn't an issue and people were driving only when they needed to, these kinds of models were useful. But today, just this very simple problem of going from point A to point B, you can already see incorporates a lot of additional things. So for instance, my values or my notion of what shortest mean may or may not include the number of turns that I have to take, maybe the number of left turns if I'm driving here in the US. So what we slowly start doing is looking into these classical problems which form the backbone of many of these more modern algorithms, and try to understand how we are embedding our values. And again, going back to David's talk, he mentioned that these objective functions that we are talking about encode people's values. So whose values are being encoded here? So, I guess I can take one example and talk excessively about it, but I have a few more thoughts, so I'll keep going. But if you have any question, just please feel free to interrupt. We will stop when the talk is supposed to stop at 4. And we have all these modern algorithms. I guess this is what all the excitement is about. This has brought the whole barrage of AI tools to public, and everybody is talking about AI. So not all algorithms are equal in some sense. Some algorithms are more important than the others. So the most basic algorithmic task, like selecting a set of objects from a large set of objects. This is in an algorithms class, I'm guessing nobody would even, no algorithms professor worth its, salt would even consider teaching this simple problem, because all it requires is just associating usefulness to each of these elements in the set and picking out the elements which maximize this notion of utility. But this problem underlies so many relevant applications where we have seen all kinds of issues. So for instance, in recruiting, user recommendations, search, and so on and so forth. Other problems which arise, very basic problems in optimization, are things like ranking. Again, a very old algorithmic task, optimization task, but has been shown how and has been used, and it is used. When you open your Twitter or Facebook or Instagram or whatever, this is the core. It selects a subset of tweets and then ranks them and shows it on your feed. So who decides what to show and how is it ranked? Well, one of the assumptions is that people somehow consume information from top to bottom. This could be different if you were coming from a planet where you read from bottom to top. But given this, what object to place where, the goals are to maximize attention, engagement, and so on. Something that has been driving a lot of content on the web is what is called personalization. Now here, the idea is, again, using an optimization algorithm, a content selection algorithm creates a personalized feed for a user. And the user is restricted to provide a very limited amount of feedback to the algorithm. And the reason for the user to provide a very limited amount of feedback to the algorithm is because the algorithm in the end also has to be able to take that information and use it meaningfully. This is the world of personalization, and this has led to negative consequences such as polarization in the opinion space, which is also a type of bias. What else? Well, classification is probably where most people would start talking about AI. I would say because this is where some kind of explicit learning is happening, where you have a bunch of data points and you want to decide, let's say, who to give a bank loan or who to admit in a college or not. Again, a whole theory about this, a very successful theory, but does not at all discuss, well, up to some point, did not discuss at all what are we optimizing, what loss function shall we use, how to represent data points. If in this audience I asked this very basic question, maybe if I had more time, I would take that poll, rate yourself on a scale from 0 to 10, how you consider yourself, how well educated you consider yourself. You will see that I'll get a divergence of answers for even you will not find a consensus of people who think 0 is the best or 10 is the best, maybe, or if I had said 1 to 10, maybe 1 is the best or 10 is the best. So, but we are encoding this information, which is not numerical, using numbers. And in that process, we are, including our values as well. So it's not just loss functions, it's about how we are representing data, how we are choosing, what aspects of data are we choosing to represent. And this is all encoding our values. And then there is all this stuff, which I guess here nobody knows about, right? ChatGPT, yeah. So what is what's my argument? My argument is that something very obvious, that we do not, the algorithms and humans do not exist in separation. We have to think about this together. And if you want good algorithms, in the end, there is no way out than actually debugging humanity. I think David kind of alluded to it by being more mindful or being more aware of how we are producing data, how we are, incorporating our values inside these algorithmic systems and so on. So it's really a mirror. I wouldn't say it's a lens because it's kind of a reflection of who we are in some sense. So, but that's a philosophical point. I'm happy to talk about it if somebody's interested. Okay, so these are all the issues which started coming up starting around 2013, 14. And algorithms can be biased, including large language models. They can violate privacy. All of these were unintentional consequences. Algorithms can be brittle. This, in my opinion, was a pretty sophisticated attack on images where you could add some imperceptible noise and change the classifier significantly. Yeah, and I think when these things come up, and by now you see it's about 10 years old, people were really surprised. Oh, wow, how could this happen? How could that happen? And now there's this growing problem of algorithms that can misinform, which is again driven by bad actors. So a little bit more mathematically, algorithm design is a human process. In each and every step of this process, human decisions are involved. These are design choices. These are made by humans. These are driven by human motivations, and often many humans are involved, and some of the motivations make it, some of the motivations don't. So the question that I think we should be asking is, who decides and who benefits and who is harmed? So when we are analyzing an algorithmic system through this lens of awareness, these are the things that we should be talking about. So Yeah, so what are potential reasons of failure? Well, this slide is not exhaustive in any way, but I guess models may very sparsely and be able to encode issues or people's concern about fairness, privacy, robustness, and there's no obvious way how these things will correlate to things like accuracy or utility and so on. One of the things that I have been working on is this second bullet, which is data is not what it seems, no matter what you think. Data is output of an observer. So most of the time, we don't even know what we are looking for. It may not even have a mathematical representation. And even if it does, the act of measurement might make it inaccurate. So people might behave strategically, noise could get added, the observers might have biases, implicit biases, explicit biases, and all kinds of societal biases might be encoded. So what we are seeing is not reality. So in that sense, the mirror that I referred to is not even an accurate mirror of reality. So without even talking about good and bad. So one of my research goals is to try to understand how we can design algorithms which can work with this inaccurate data if in addition we also have some model of how the data is being transformed from the true, whatever its true representation is, to this observer. And I just added this slide mostly to kind of, if this question comes up, and I think David already mentioned this, I was not planning to add this slide, but fairness is not one thing. It is many, many things. There are many, many metrics. There is a notion of group fairness, individual fairness, outcome dependent, outcome independent, true positive, false positive, equal representation, proportional representation, and this list is probably far from complete. The point is, when I started working in this area, I realized that my goal as a good computer scientist, who's not really trained as an ethicist or as a philosopher, is not to choose a particular notion of fairness. It is to design algorithms which can take as input any notion of fairness and then deliver on that front. So if you say, I want a classifier which has, which is, let's say, which is fair with respect to statistical parity, then my goal would be to allow the user to be able to encode statistical parity and not having a separate algorithm for each of these notions of fairness. So that was my main contribution for a very long time. I was working on designing, frameworks. So this is joint work with a bunch of people. In the end, and analyzing things like the price of fairness, the moment you incorporate constraints, how much does the objective function change? And also, when you include these kinds of fairness constraints, who pays the price of this additional computational burden? Since a lot of considerations, and especially in businesses, are governed by cost, there is also often a computational cost associated to adding a constraint. If you have a deep learning algorithm, it is doing something very fast. Now you want to constrain it. It's not often obvious that you can do the same thing in the same amount of time. So who's going to pay the price of all this stuff? And I think David mentioned that the executive order is trying to mitigate some of these costs. But the first series of my work, or the first phase of my work, even being a researcher in this area, assume that we have access to true data. In the last year or so, I've been looking at when this assumption is not true. There are many, many examples from the real world where this assumption is just not true. And now the question arises, how do we design fair algorithms in the presence of data which is not the true data. And this is kind of a four-pronged approach, the methodology, which is, I think the first step is to develop mathematical models of how true data gets transformed. And here again, ideas from behavioral economics, which is also a type of optimization. People, when they are, when you're making a measurement on a system, on a person, or a person is reporting, they are probably optimizing. There's something being optimized. It's hard to get around the language of optimization. So using optimization to understand this transformation, then once we have some kind of a meta model of how this is transformed, to redesign this algorithm, because this algorithm will no longer serve the purpose it was supposed to. I'm also a mathematician, so I like to have quantitative guarantees about the results of the algorithm. And finally, we also work on validating all of this on real world data. So that's the pipeline that some of my recent work in this direction has been following. So to summarize, artificial algorithms have made tremendous progress in trying to mimic natural algorithms, which remains currently the goal. This has been an outcome of not just data, but also models, human feedback, compute, and so on and so forth. There are lots of positives that everybody knows about, but there are also negatives. And the negatives are leading to calls for designing these algorithms or redesigning these algorithms to keep in mind the context. These algorithms be more aware of where are they going to be applied, who the stakeholders are, who will they harm, and so on. And this requires an understanding of how we are embedding our values and ethics in data, in collecting data, even deciding what data to collect and what aspects of data to collect, to models and so on. Also, I think this is related to the notion of loss functions. I mean, the loss functions somehow encode our notion of intelligence, and this is also super narrow. I mean, for somebody who works in this area and who has also worked on just, broadly biological intelligence, I feel like the notions of intelligence or the notions of how good an algorithm's utility is seem very narrow. And as I said in the beginning, for me, ultimately, this the ultimate goal of all of this is, to debug humanity, because in the end, once we understand how we are embedding our values into these algorithms, we're also learning about ourselves. And if we are not becoming more aware of what values do we care about, what values we don't care about, what happens to our data which we are generating, we will not be able to get out of this by just optimization. So I'll stop here and take questions. Thank you.
Great, thank you so much. Who would like to start with the first question for Nisheeth?
I can. Oops, go ahead.
Oh, sorry. Hi, Dr. Vishnoi. I have one question. This is wonderful presentations. I really liked it. So what challenges exist in finding the right balance between human interventions and autonomy in AI decision making?
Well, I think I am not an expert in that, but I can try to address that question. I think the challenges at the moment include understanding what these AI systems are capable of doing. So one of the things we are seeing with modern AI systems is the notion of emergence. And something I didn't talk about, but what this roughly means is, I can give you an example. So for example, if let's say you take two sets of languages, you take data generated from two completely different languages. Now, both of these languages have a goal, which is to communicate human thought in these two different civilizations. These two civilizations are connected in the sense that they are both of human civilizations. They're not one civilization here, one civilization there. So assuming that there is some commonness in the human civilization, which is generating data in language 1 and language 2, and if you use one algorithm to learn how to make predictions for language 1 and language 2, so one algorithm, it is natural that it gains some ability to generalize. And what is not clear is to what extent is this generalization? What can you learn by learning two different languages in a single framework? I don't know. I mean, we have Misha here, who's an expert. He might tell you more. But so for me, without understanding these kinds of questions, about these AI systems, I don't know how to comment on autonomy, because I mean, in the context of these large language models or generative AI, I think understanding generalization in some high level way becomes important, because what are we guarding against? I don't know. So I'm sorry, I did not really answer your question, but I just had a couple of thoughts on that.
Well, it's completely fine. Thank you so much.
Okay, so I mean, it's really interesting, especially at the end, Nisheeth, when you say that there's a last recent interest where you try to find parameterize the model, going from, I guess, exactly what David was saying earlier, this kind of latent space that's generated as observables, what's we consider to be the data, which is not the true data, right? But I'm wondering, to create the model there, to parameterize there, isn't that another source for, I mean, it's another decision to make. How do you know that that's a good model, that's the right model? Yeah.
No, it's absolutely right. And I think one thing that the audience should get from both our talks is that the more you start thinking about values and ethics and so on, you might have a thought that, okay, you know what, let's just go back to the old algorithm design where we don't have to think about anything. Because now with this awareness, it sounds overwhelming, because, okay, so then, we are, so for example, so what am I referring to? I mean, I guess everybody here uses online shopping tools, such as Amazon, right? How many people here leave a review there? Probably very small, but how many people read reviews? Almost everybody. So who are these people who are leaving reviews? And how are individuals interpreting these reviews, right? And this, as you can see already that, whoever, people have different ways to interpret information, right? So for instance, you could look at the average rating, you could look at the distribution of rating, you could have an upper bound on how many 1 stars it has, and which one should we choose? As if I was, let's say, this corporation which is trying to show you, how do I do that? So what is also happening is that all this AI technology has enabled the proliferation of human values. So human values are not finite. I mean, they're not contained in anything. It's from a purely mathematical point of view, you can take any two values and create more values. In fact, as I think David already hinted to, that anything can be interpreted as a value, right? I mean, trustworthy AI could be trustworthy for one group, but may be completely untrustworthy for another group. So what we are seeing now is people becoming more and more high dimensional in the space of values, right? So this question that you're asking is really a very interesting question. And I think the way I see it is like atoms moving in this room or molecules moving in this room. If I start looking at each and every individual molecule, then its trajectory, its motion will be very chaotic and very different. What am I interested in at the end of the day? If I'm interested in predicting the temperature of the room, do I really need to care about each and every molecule's trajectory? So I think when we are developing large scale AI systems, we have to take a broader context into account. We cannot incorporate each and every individual's values inside these systems. It's just not possible. I mean, you can prove theorems about this. So so I think that this has to become a more context-based. Where is a particular system used? What its impact at a gross level on a certain group of people would be? That becomes, I think, the guiding force in deciding how finely to model human behavior, or how finely to incorporate things like fairness and bias and privacy into these systems.
Thanks.
So we'll end on one final opportunity for each of you to answer the final question. Nisheeth, you had used this phrase a couple times, debug humanity, which I wrote down because it's an interesting concept to think of. So knowing that as people, we have internal biases, some of which we're aware of, most of which we're not. I think it's reasonable to assume that most AI is going to have biases as well, some known, most unknown. So how would we as general users, as students in early career, as researchers, balance the healthy skepticism of knowing that bias is in AI with the cynicism that might come out of, oh, we can't trust anything, I don't want to have anything to do with this? Nisheeth and David, could you give us your 30-second thoughts of that balance between healthy skepticism with AI bias and cynicism?
David, go ahead first. I mean, I cannot answer anything in 30 seconds.
The very quick answer I would say is to recognize that, yeah, humans are biased in lots of ways. Algorithms are biased in lots of ways. And instead of viewing bias as always a negative, we should view it as an opportunity. Bias variance trade-off. We use bias in positive ways all the time. So the question shouldn't be, how do we become less biased? It should be, which are the biases that we want to have, and how do we develop biases for fairness, biases in favor of honesty, biases in favor of caring for others. We should do that as humans. We should do that with our AI.
So I have two small kids, and I'm going to take it as close to 30 seconds as possible, okay? And one of the things that just like when we train them to think about others when formulating their responses, formulating their behavior, I think at a very early age, we have to start training kids about the impact that the data that they're producing, how they're interacting with these algorithms is affecting themselves and the society at large. So we already do that. I mean, we do inculcate values in kids. It's with respect to a specific computational model, which is that I'm interacting with other people. I think we need to start including AI agents into this computational system and let these kids. So I actually am considering in the fall to go to elementary schools and start talking about algorithms such as AI algorithms. And when I visited some of these things in the New Haven area in the last fall, and I proposed this idea, I felt an opposition, and I said, look, I mean, we do all kinds of things. We teach, we are teaching 6-year-olds, 7-year-olds sex education, and they're not having sex. I mean, hopefully until they are older, right? So it's in some sense explaining to them the basic core ideas about AI, about algorithms, so that when they actually start using a phone or interacting with media, social media or whatever, they understand. And so they understand how to reveal their choices, how, what impact it could have on the broader world. This kind of education currently, at least in this area where I live, is missing. And I think this is where I am looking forward to contribute in the near future.
Fascinating.
It was not 30 seconds, Jody, I'm sorry.
No, that was definitely worth the 90 seconds it took. Thank you both for your time today. I'm glad so many were able to join us. This will be recorded and it'll be posted on our TILOS YouTube channel in the next few days. So thank you again, and thank you all for coming. Have a great day.
Thank you, everyone.
Thank you all.